Okay, so 1 minute, then start na tayo. Ano? And then we'll just record this meeting para dun sa iba para makahabol sila. Okay? Okay. Ayan. Okay, so good morning po. So hopefully you can see my screen. Okay, so continuation po tayo and then focusing our attention on the layout design. So last time, ang ginagawa lang natin was trial and error when we're evaluating the layout, right? Given yung prompt to chart, ayan, i-evaluate lang natin. And then we'll come up with a design, yung ating block diagram. And then trying to minimize the number of non-adjacent, um, number of non-adjacencies or non-adjacent departments. But this time, gagawa tayo ng algorithm para dito. Okay? But before that, kailangan muna natin ma-understand yung, again, just to have a review, yung basic layout types, yung SLP natin or systematic layout planning or tinatawag din nating Wooder's grid. And then introduce natin yung computerized layout planning. And then how will we evaluate the layout and construct the layout as part of what algorithm will we choose. Okay, so once again, ito yung basic layout types. So pag ang ating volume ay mataas or madami tayong production with less variety, let's say for example, 2 klase lang yung items na pinoproduce natin, ang tawag sa layout na yun ay product layout. And then yung department na yun, they call it as a product planning department. And then pag mga cases na mababa yung volume na pinoproduce natin and then iilan lang yung unit na ginagawa natin, for example, mga eroplano, bahay, that could be one example. So tinatawag natin sang fixed location layout. Okay? And then pag mataas naman yung variety, maraming klase ng items tayong pinoproduce. And then given ako konti lang naman yung volume sa kada item na yun, tawag sa kanya ay process layout or process focused layout. Then kung mga cases na medyo hindi naman sa sobrang dami, hindi naman sa sobrang taas ng ating volume, sobrang daming klaseng items na ipoproduce. So, in between that, may tinatawag tayong cell manufacturing or group technology layout. Okay? Ayan. So, pag product layout, flow shop ang tawag sa kanya. Group technology naman, pag po ginugroup natin yung mga lines into product families. And then job shop naman po, pag focus tayo halimbawa sa process. And then static for, yun nga, fixed location. And then there are several other specialized layout like warehouses, how will you build one, then offices na magde-define ng functions ng kada departments and even large shopping centers and the likes. So ito nga po, in doing layout design, what we normally do was this block diagramming. Hindi naman po tayo focus sa ngayon sa detail layout na kung saan kailangan ma-determine natin saan mismong location ilalagay. Halimbawa, yung mga machines natin, yung mga conveyor system, yung mga cabinet, yung mga racks, yung mga tools, saan siya ilalagay. So ito, again, this requires a lot of work. And you have to understand yung point of use ng bawat item, bawat machines natin. Okay? But in block layout, block diagramming, we're just showing in terms of blocks, naka-square or rectangle siya, yung location kung nasaan yung mga departments na yun, and then kung gaano kalawak or ano yung area ng mga departments na yun. So last time, nung ginagawa natin tong block diagramming, di ba equal yung kanyang area ng ating mga blocks. But this time, we'll consider yung saktong area ng kada isang department. Okay? Kasi at the end of the day, may mga departments talaga na kailangan medium size lang or maliit lang. Or merong mga, for example, location like warehouse, like storage location, na kailangan talaga mas malaki as compared to other departments or other locations. Okay? So this time, i-consider na natin yung area. Okay. So, but part of that, before you use any of the two types of layout design, you have to really understand ano bang klaseng production ang ginagawa natin. Okay? Maybe fixed product layout. So ito nga po, pag product layout is standardized, mataas yung demand, stable yung demand. So tuloy-tuloy yung process. For example, ito. Napakita na natin to last time. So yung product, focus tayo sa product. Ito yung product 1. Ito yung ina-undergo niyang process. Ito yung product 2, product 3, product 4. So kanya-kanyang linya. Product lines. Okay, focus tayo sa kung ano yung kayang gawin natin sa kada product. Okay? So besides mataas naman yung ating volume. Ngayon, anong advantages niya? Very smooth production, mabilis yung production, mataas yung production rate, mababa yung cost kasi madami tayo na po-produce as compared sa unit of inputs natin kaya mas mababa yung cost per unit. And then may utilize natin na maayos yung kada machine knowing na mataas nga yung volume, yung kada line, may movement, may actions, nagalaw kumbaga. And then mababa yung handling cost kasi wala masyadong transferring na nangyayari. Isang diretsuhan. Ito yung process 1, process 2 ng isang product line. Dire-diretso lamang siya. So less material handling cost. And then wala masyadong personal na required kasi hindi naman nga masyadong nagmo-move yung mga parts. And then besides, dire-diretso nga yung ating flow. And then yun, hindi masyadong kailangan ng technical skills para sa mga tao kasi nga kailangan lang, for example, monitoring. And then hindi siya kailangan ganun ka-skillful na alam ng operator yung ginagawa ng other process. Kumbaga specific siya dun sa particular process na yon. And then mababa rin yung work in process kasi nga tuloy-tuloy yung production. Kung mataas yung volume, so alam mo, mako-consume yung mga parts na pre-produced mo. However, high machine utilization is normally risky. So what if guys, what if nasira yung drilling machine dito or yung grinding process mo? So ano mangyayari dito sa product line na to? Titigil. Malinaw? So that is why risky pag overutilize yung ating mga machines. hindi naman pwedeng i-transfer. So, ang mangyayari, halimbawa, nasira yung drilling. So, pupunta siya dito. Ayan, pupunta siya dun sa isang line, tapos gagamitin siya. Babalik siya dito sa line 2, sa line 1. So, which is ayaw nating mangyari kasi nagkakaroon ng obstruction yung other product lines. Okay? And then process performance depends on the bottleneck. Kung ano yung halimbawa, ito, ang kayang i-mag-produce lang tayo ng sa late machine, halimbawa, ang kayang i-process niya ay 70 pieces. Sorry. 70 pieces per hour. Ito, 80 pieces per hour. Then itong grinding process, 20 pieces per hour. And then itong drilling, 80 pieces per hour. Ibig sabihin, ito yung nagkukos ng bottleneck. And then as a result, hindi tayo pwedeng mag-produce ng mas marami pa sa 220. Ibig sabihin, ito, ang line capacity ay just 20 pieces kada oras. Nalilimit. Unlike for example, pag meron tayong shared machines, halimbawa, so posible ma-address yung bottlenecks natin. Okay? And also, it may not be flexible enough for a new product design or any volume changes. Halimbawa, pag bumaba yung demand ng product natin, di ba? So as a result, mahirap. Hindi natin may utilize ng maayos yung machines. And then, even if let's say design siya for 20 pieces and ang demand mo lang naman pala ay halimbawa 1 or 20 pieces per week. So, hindi natin na-utilize ng maayos. Mahirap kumbaga na i-transfer or i-move itong mga machines na to dito sa other lines. Para ma-utilize natin sila. Kasi itong mga machines na to ay assigned or itong mga processes na to ay assigned for the product line. Okay? And then, yun nga, paulit-ulit tayo nagawa and hindi kailangan ng skill yung tao or walang nangyayaring movement sa tao. Kumbaga, yung tao, expertise niya lang yung isang process na yun. So, less nga naman yung motivation and mataas na investment yung required kasi nga, yung product line, may kanya-kanyang naka-aside na machines. So, even if yung isang machine natin ay gagamitin dun sa other process, other product line, hindi natin magawang ma-share. Kasi yun nga, ang ating product is designed as a product layout. Ang ating process or ang ating manufacturing is designed for a product layout. Okay? Next, for the fixed product layout, yun nga, fixed. Ibig sabihin, para itong may common area na kung saan yung mga process pumupunta dun sa common area na yun. So that combines all workstations required within or with the area required for staging the product. So normally, yung mga products na ginagawa sa isang product layout ay masyadong malaki, mahirap magkaroon ng maraming movement, and yung demand ay hindi masyadong consistent. Okay? And then, yun nga, advantages, less material movement is reduced kasi nga yung ating finished good or yung ating product ay mismong nandun na sa isang common area kung nasan siya ini-stage. Then, individual can complete the whole process, job enrichment opportunities kasi nga po yung mga tao can move from one process to another. So, kumbaga, pag dito ginagawa yung product, itong tao na to, he could know other processes. Anong ginagawa dun sa iba. So, again, that provides some enrichment on their skills. And then, is highly flexible and can accommodate any changes in demand, which is true. For example, nagkaroon ng change sa design ng bangka or sa barko, madaling magkakaroon ng revisions. Kasi nga, nandito na rin naman sila. Napapag-usapan nila, madali yung coordinations. Ngayon, the problem is, masyadong marami personnel kasi nga, yung product natin nandun lang sa isang location. So, ibig sabihin, yung tao and then yung equipment, yun yung gumagalaw. Nagkakaroon din ng possible duplication of equipment. And then, kailangan ng greater worker skills, hindi siya suitable for high production kasi nga normally yung product natin ay difficult to move, and then close control and coordination in scheduling. Any miss sa communication can abrupt or can cause damage dun sa overall product making. Okay? Then process layout, yun nga, pag mataas yung variety natin, normally process focus tayo. Yung mga machines natin ay shared, or can produce several items. Ito, pinaliwanag natin last time. Ito yung product line. Ito yung isang product that can undergo, several process, or hindi naman necessary na lahat ng process kailangan daanan, or yung combination ng processes ay pwede magkakaiba. So, ito pong process layout is normally, yun nga, pag mataas yung variety, marami tayong klaseng items. And then for intermittent demand. Hindi kuminsan mataas, kuminsan mababa. And then for the layout, identical workstations in the departments, kagaya po nito, pare-pareho sila. And then we're combining similar departments. For example, drilling department, assembly department, sama-sama na sila. Okay? Now, what are the pros and cons? Yun nga, machine utilization, definitely, i-improve natin. Pero, mataas naman yung material handling kasi nga, ang daming movement na nangyayari. And then flexible in allocating personnel and equipment, robust against any machine breakdowns. For example, nasira yung isang milling machine. So as a result, may kayang suportahan ng other milling machines. Hindi masyado nating hindi masyadong makaka-impact dun sa overall run natin. And then robust against design or any volume changes, specialized supervision is also possible. However, the cons, mataas yung ating work in process. Ibig sabihin, ito yung pag sinabing work in process, ito yung mga parts na hindi pa naman tapos or ka-undergo lang dun sa isang process na yun. For example, drilling. Natapos ng drilling, so may stocks ka dyan. So those stocks are called work in process or WIP inventories. Then longer production lines, kasi nga, posible na maraming pinagdadaan ng processes. Then difficult to schedule the jobs, which is true. Kasi nga, posible na yung machine na yun or yung mga machines na yun may niraran pang ibang item given na mataas yung variety mo. And then higher skills are required. And then also, mahirap ma-analyze yung process performance. Kasi nga, nagva-vary yung number of machines. So yung posible yung output nila, mahirap ma-identify. Ilan ba yung nakaplan dito? For example, nakaplan dito ay 3 pieces ng A, B, and C. So they produce 9 pieces. Pero 9 pieces of A o product A. So mahirap nga naman na i-analyze natin yung process performance looking in general. Okay? Product family, ito naman po for group technology. Okay, ginugroup natin into families. We're combining workstations that are required for the family or products. So kagaya nito, ito din, ito din, ito din. So cell manufacturing po ang tawag dito. Okay, so we're getting the benefits both from process and product layouts, mataas yung machine utilization, smooth lines, and then nagkaroon ng team atmosphere, mas mabilis yung communication. However, ito yung kailangan. General supervision is required. Okay, also, skills requirement, kailangan mataas. And how will you balance manufacturing cells? This is really a problem. How will you group? How will you form a manufacturing cell? That is quite challenging. Okay? Ngayon, upon knowing yung different classes or different types ng ating layouts, we should understand ano ba yung procedure na ating pagdadaanan dito. Are we doing a facility from a scratch, yung totally walang layout, or tayo magagawa ng layout, or that layout we must improve. Okay? So ito po yung improvement type method. Okay, so sa construction type method, yun nga, developing a new layout from scratch, and then layout and material handling system should be designed simultaneously. So habang nagkikreate ka ng layout, hindi mo lang basta tinitingnan yung saan ilalagay yung department na to. You should also consider Material handling systems. Halimbawa, conveyor. So, anong itsura ng conveyor system mo? Nasa gitna lang ba siya? Ano yung mga departments na kailangan niyang daanan? Okay? Ngayon, pag improvement type method naman po, we're generally creating a layout or creating or developing a layout alternatives from an existing layout. Okay, so if we are looking to do some revision on the layout, so generally speaking, what we're doing is how will we make use of material handling system more effectively? Okay? Paano natin mapapabilis yung movement ng mga parts na nag-exist na sa warehouse natin or nag-exist sa planta natin? Okay? So ito po normally yung mga projects na pagpapagdaanan ninyo for improvement types. Okay? Kasi itong construction type normally hindi naman natin yan forte. Mas alam yan halimbawa ng mga other engineers, civil engineers. Ayan. But definitely we can have some inputs. Like for example, if we are very familiar on how the product is to be produced, ano ang mga machines na kailangan. So yun yung inputs na may ibigay natin. What is the flow for that material or for that products. Okay? Ngayon, in doing our layout, facility layout, may it be construction type or improvement type layout, meron tayong mga sinusunod na mga procedures dito. Actually, these are very conceptual. But the thing here is parang you have to gather data first. You have to understand your process first before doing any other revisions, any construction, any development. Okay? So, meron tayong Naddlers, Immers, Apples, Reads, Muller, Systematic Layout. So, medyo mga makaluma, again, that's part of the traditional layout procedure, which is still being used or used as a basis on our facility layout design. So, dito sa Naddler system, you're looking for or you're aiming, targeting for a theoretical ideal system. Okay, kumbaga parang may step by step dito. This is your present system. How will you install a recommendation system? Ano yung mga alternatives na nandyan? And then until you reach that theoretical ideal system. Ayun, parang hierarchy of needs lang din yan. So itong ating first step, second step, third step, hanggang sa maabot natin yung theoretical. Again, very normal naman itong Naddler's ideal system approach. Dito naman sa Immer's basic steps, the analysis should be composed of 3 simple steps, which can be applied to any type of problem. 1, state mo ang problema. Ano ang current status? Identify the flows, and then convert the flow lines to machine lines. Okay? So, machine lines, so that involves yung alam mo yung processes, and then saan mo dapat ilagay yung mga machines na kailangan in order for us to support that flow. Okay? So that's the immerse basic steps. So again, current state hanggang sa ma-achieve mo yung future state. Dito naman sa Apple's plant layout procedure, so almost the same concept as the immerse basic steps, whereas you're identifying your problem. You're determining the flow of the problem, identifying ano yung kailangang material handling equipment, ilang workstations ba yung kailangan mo, sino-sino yung ano-ano yung mga related activities, and then nasaan dapat yung storage, other auxiliary activities, gaano karami yung required space, how will you allocate those activities, those spaces for each department into the total, is to build up or to relate it with the total space. And then you have to consider saang building type ba, master layout, until you get approval, and then install that layout. And then of course, follow up on the implementation of the layout. Okay? So again, it starts with getting the data, getting the flow, identifying what are the machines needed, identifying the relationship between each activities, or identifying each activities, then identifying all the activities, how each activities relate to each other, and then other supporting details. ano yung area requirements. How will you compare that total area required versus the total area available? Okay? And ayan, hanggang sa makagawa na tayo ng layout. Okay, so this is Apple's plant layout procedure. Dito naman sa reads, almost the same process. Kung mapapansin nyo, analyze the problem, okay, or analyze the flow of the product. Ayan, processes, ganun din. Initial layout, makikreate tayo. Workstations, then storage, then aisle width nga. Iko-consider na rito yung aisle width. Halimbawa, aisle width is, for example, ayan, ito yung ating mga processes. Ano yung aisle width na yan? Okay? Gaano yung kalayo dapat? Okay, and then this one considers yung pangangailangan na ng mga personnel. For example, that this includes yung mga restroom, mga parking spaces, and then yung mga yung sa aircon, yung sa mga ganun na pangangailangan. Ano? And then survey, plan services, and of course, design for future expansion. Ano? So this is the concept from READS. So kailangan ready tayo, yung layout natin ay ready for future expansion. Okay? So ito yung process, layout planning chart dun sa reads process. So tinitingnan natin yung flow, ina-identify natin yung mga parts, gaano karaming operators yung kailangan, gaano karaming departments, tinitingnan natin yung flow. Ayan, ano yung kailangan machines, machine fraction, utilization, ano yung mga combinations na kailangan, ano yung mga material handling equipments na kailangan. Okay? So ito po yung planning layout or layout planning chart according kay Reeds. Ngayon, the most popular of all the layout procedures ay yung SLP natin or Systematic Layout Planning Procedure. So almost the same, pinagsama-sama yung mga other concepts. So starting with the data, ano-ano yung mga kailangan nating data. That includes ano ba yung product na ipoproduce natin, ano yung mga raw materials, ano yung flow, ayan. Ano yung mga existing machines na meron tayo, how will it relate, how departments relate to one another, how close should it be until ma-establish natin yung relationship diagram. So kung dati, yung relationship diagram, we're just focused on either of the two, flow, ayan, from two chart, activity relationship, yung closeness. Pero this time po, i-consider natin silang dalawa. Kumbaga, i-pairwise natin. Okay? Mag-pairwise tayo, yung from to, and then yung closeness. Okay? After, kasi we're not just looking on total distance traveled, di ba? Hindi lang yun sapat. Kailangan mala-identify din natin, gaano ba dapat ka-close sila? Okay? Kasi may instance sa halimbawa na kailangan talaga mahaba yung movement, malayo yung department to one another. So, lalabas sa distance, malayo, pero hindi naman siya kailangang magkadikit. Di ba? So, kailangan nating mapag-relate siya through a relationship diagram. And then, yun nga, kailangan natin may consider yung area available, space requirements, gaano kalawak na area yung kailangan ko per department, and compare it with what is available. After nun, may establish natin yung space relationship diagram. Again, parang magkakreate. Ito kasi parang magkikreate lang tayo ng relationship diagram. Ayan, pwede tayo mag-create ng blocks. Pero once na kinonsider na natin to, posible pala yung mga blocks ay hindi pare-pareho. Okay? So ayan, and then after that, we can of course consider any modifications or any other alternatives, and then of course practical limitations. For example, yung machine nakafix na doon, hindi na pwedeng i-move, or may walls na magli-limit dun sa ating maging movement. So we have to consider that on our layouting. After that, you could develop several layout alternatives and then evaluate each alternative to determine which is the best fit. Ano? Okay, so ito po yung ating sinusunod normally, yung SLP. SLP or Systematic Layout Planning. So this was developed by Mooder, sorry. Okay, so going back here, ano daw yung mga information na kailangan nating kunin? Ito yung na-discuss natin last time. Product, process, and schedule design. We should understand all of them in order for us to develop a layout plan. Okay? Yan. So, kailangan nating mag-design din or design for automation. It could be considered still. And then dimensional reduction, parts elimination, parts standardization. So as you can see here, the cost of assembly is reduced if it occurs in a single dimension. The complexity of programming a robot increases geometrically with the number of assembly dimensions. If the complex parts can be produced, the number of parts can be reduced, which is true. Kung kaya naman nating i-print halimbawa yung mga complex parts, for example, may complex parts halimbawa siya. So instead na ipoproduce ko siya ng 2 layers na ganyan, kaya ko naman pala siyang gawin isa. So yung complexity or number of parts natin ay ma-reduce. Okay? Okay. So also schedule design. So it allows us to know gaano kadami pa yung pinuproduce kasi we have to anticipate. Ito bang linya na to, ito bang area na to na ilalagay ko sa facility ko ay makatarungan ba na malawak yung area na yun? Given na mababa yung demand, mataas yung demand, so on and so forth. So you should understand or you should weigh in yung market forecast. May future ba yung linya na to? Or itong linya na to, kahit wag ko na munang pakialaman kasi over time, mawawala rin naman yan. Okay? Okay, so other information needed for the product design. Ito, na-cover natin last time. So you should understand yung flow, extruded diagram, parts list, bill of materials, assembly chart, about the process. You should know yung flow niya by the route sheet, precedence diagram, what comes first, what comes next, and then operations process chart. Okay, it could be processing, process chart, assembly chart. Yan. And with regards to schedule, you should understand how fast or the volume ng ating production. And with regards to product mix, product mix, it could be several items. For example, product A, product B, product C, product D, ipoproduce natin siya at the same time. Okay, you should consider that as well. And also yung market forecast and yung plano para sa kanya. Gaano ba ka-frequent natin ipoproduce si product A in the long run? Si product B, ganito lang dapat yung run niya. Then, ito si product C. Then, ito si product D. Okay, so you should understand the schedule. Okay, in order for you to come up with a better plan. Okay, so ito nga po, yung mga bills of material, assembly diagram, from to chart. So with regards to the flow, from to chart, and then flow process chart. And then ito yung activity relationship natin. So ito yung closeness na dapat kailangan sa kanya. Okay. And then, na-establish natin yung activity relationship diagram. Ayan, the relationship positions special activities partially. Ito po yung mga IEOUX, yung ginagawa natin last time. So naglagay siya ng 4 na lines for A, for E naman 3 ang lines, for I 2 ang lines, and then for ordinary 1 line, and then pag unimportant so walang line, and then pag rigid so siya ay dapat magkalayo. So normally these are presented in two-dimensional top view. Okay, after that, so ayan, this time po, i-consider na natin yung mga space requirements. For example, yung ito, kailangan daw ng 781 square meter. And then other supporting facilities, kailangan din nating ma-address. So all in all, kailangan nating mai-total yan and compare with available space. Okay? So ito po yung ginawa niya. Then ito yung relationship diagram. So once again, mula sa kanina nating ginawa na activity relationship diagram, ito po natapos na natin, kailangan nating ma-generate, ma-consider yung area bounded by each department. Okay, and that can be done through a space relationship diagram. So that combines the relationship diagram and or that combines the space requirements sa kada isa and then with the relationship diagram. So imagine, if nagpa-block diagramming lang tayo, so ganito yung ating magiging analysis. Tama? But in reality, may mga area pala tayo na kailangan malaki, may mga area na kailangan maliit. So that could impact yung adjacencies or yung kailangang maging adjacent. For example, may isa kang area na ganyan. Ayan. Ito si A, ito si B, ito si C, ito si D. So, halimbawa, yung D kailangan daw adjacent kay A. Okay, na-address. Di ba? Si B kailangan adjacent kay A, kay D, kay C. Si C kailangan adjacent sa lahat din. Di ba? So, imagine, kung ang gagawin lang natin, halimbawa, sige, dagdagan natin dito ng E. Halimbawa, ganito yung gagawin natin. Ito si A, ito si B, ito si C, ito si D, ito si E. Yan. Di ba parang mapapansin mo dito? Okay, hindi na sila adjacent. But in this concept, adjacent na sila. Nakuha? Sorry. Nakuha din yung adjacency, yung impact niya sa adjacencies. Okay? Ngayon, ayun nga, pwede rin ganito yung gawin nating flow. So, and from here, pwede nating mai-present into this one. So, ito yung mga areas na kailangan sa kanila. And then, ito yung importance. Okay? And also, part of your layout design, you should always look for alternatives. Okay? So, we have to conversion of space relationship diagram into several feasible block layouts. So, you'll not just present one layout. For example, itong 6. Yung area ng 6 na yun is the same as the area nito and the same as the area nito. Yung 5, yung area nito is the same as the area nito and the same as the area nito. Okay? So you should present a layout, not just a single layout, but you have to consider yung several alternatives. Okay? Okay po. So again, this is more of trial and error, I would say. Part of it are because of your intuition, the way you judge things, and of course, based on the experience. Okay? Questions so far? So, nandito na tayo sa banda dito. So, we'll be considering space requirements. Okay, now, this time. So, kung babalikan natin yung mga na-discuss last time. So, that last time, trial and error tayo. This time, gagamit na tayo ng algorithms. So, algorithm approaches are based on the relative placement of departments on the basis of their closeness. Yun nga, qualitative data, kung natatandaan nyo, through relationship chart, or quantitative data by understanding the from to, or yung ating material flow intensities. How frequent yung nangyayaring material movement. And then closeness rating, qualitative, yun nga, based on your judgment or based on the interviews that you've conducted. Okay, and then we will form or we will both input the forms and try to establish the relationship between the two. Okay, we'll develop that or will acknowledge both data, okay, or consider both data. Now, we have several algorithms that can be used here. The most popular is yung pairwise exchange method, graph-based method. Ito ginagawa natin, pero hindi na siya simpleng block diagram kasi you have to consider na yung possible area coverage. Then, yun nga, craft or tinatawag natin computerized relative allocation of facilities technique. So, which is ituturo, na-share natin yung video. Hopefully, you could or you already watched it. And then, mixed integer programming, and then SA, annealing, simulated annealing, and genetic algorithms. So, itong tatlo lang na to yung aking mai-discuss. Actually, hindi na mai-discuss, pero susubukan niya. Especially itong craft. Okay. So, ano daw po yung computerized layout planning? So, with the help of computer, natutulungan nila tayo na magkaroon ng analysis or yung mga complex computation ay mas mabilis na nagagawa through yung mga systems natin or other softwares like for example, Blockplan, Craft, Simulate, and Aldep. So yun yung mga popular na layout planning softwares. So designer must interact with multiple design bases and provide integration between them to translate the information with consistencies. For example, ito, yung area nito, guys, na-consider. Ito yung total area. Yeah. So unlike yung ating ginagawa dati, na isang ganyan lang, na pare-pareho, this time, ito, tinitingnan natin yung total area. So ito, may total area. Kailangan ma-establish natin yung closeness na sa isa't isa. Okay? Ngayon guys, may dalawang klase ng measurement dito. One is yung tinatawag nating rectilinear, the other one is Euclidean. Pag sinabing rectilinear, parang ganito siya. Ito yung hanapin natin yung centroid. Halimbawa lang po, ito yung centroid niya. Ito yung centroid ng isang iyon. So pag sinabi natin rectilinear, tinitingnan natin ito, yung total distance na yun. Okay? Yun po, yung rectilinear. Ito yung rectilinear. Pag sinabi nating Euclidean, ang Euclidean naman po ay parang Pythagorean. Ito naman po yung Euclidean. So definitely, magkaiba sila ng magiging measurement. Kasi posible na mas malayo siya in a rectilinear way as compared sa Euclidean. Okay? Yes. Or definitely, mas mahaba talaga yung rectilinear. Pero kung i-compare natin siya with other rectilinear measurement dito sa ibang department, posible maka-influence siya dun sa ating total layout design. Okay? Questions? Wala naman po. Okay? So we have this, all of our decisions or most of our decisions can be aided depending on what information is needed, what are the algorithms that we will be using, and with the help of several softwares. Ito yung mga classical softwares, Craft, Corelab, Alda, Planet, and some newer layout programs like Simoga, Factory Plan, Layout, Mcraft. Okay, so ito naman po ay yung mga ini-install na natin. Pero almost the same naman po ng input, yung mga prompt to chart, relationship chart, or relationship diagram, ganun lang din naman po. And area. So ganun lang din naman po yung input sa mga ito. Okay? Okay. So once again, ay mga information natin, we have quantitative and qualitative information. So quantitative, ito yun. So not just distances, but also considering yung total flow between two activities, two departments, yung cost, the distances. Okay? And then yung area. Then for qualitative, yung preference ng designer, preference or based on the surveys conducted. And then we can present our layout through block diagram or block plan. Okay, now, for block planning po natin, this one is the most challenging, especially kung gagamitin natin mano-mano. Okay, without the help of the software. Kasi yung area, imagine yung area, hindi naman natin alam, mahirap malaman na ang area nito ay equal sa area nito. Diba? So kung mano-mano natin i-drawing. But unlike with the help of a system, alam natin na ang area nito at area nito ay the same. Secured tayo. So therefore, nako-consider natin siya yung ating spaces, areas, dun sa ating layout planning. Okay? So for example, this one. So when we're doing graphical representation, so points and lines representation may not be convenient on our analysis. Di ba pag analyze naman tayo, ito, halimbawa, titingnan mo yung area na to. Para sa atin, mahirap mag-compare. Unlike if area yung given. Kung alam mo yung area na to, so posible magkakaroon ka ng change. Halimbawa, ito, yung area. Ito. 'Di ba? Hindi mo alam kung medyo tedious pa siya sa pagko-compute. Ano ba yung total area nito? Okay? Unlike pag alam mo na yung area, so madali nang magkaroon ng graphical representation. So, ayan. So, in graphical representation, it can be discrete or continuous. Pag naman discrete, ganito po ang itsura. And then, so grid size and computational burden, yan po. Pero with the help of a system, medyo madali na to. Unlike ito na, for example, ang daling malaman yung area. Ito, medyo complex yung area na malaman. Okay? So, once again, those are two ways to do a graphical representation. This is what we normally do, yung block diagramming natin. Pero with the help of system, pwede tayong makadevelop ng discrete or yan, saktuhang value natin. Okay, dito po sa graphical representation, we're treating a unit area square. So ito po, unit area square, yung isang box na yon. Ito po yung unit area square. So halimbawa ito, ano po yung total area niya? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sabihin natin 12 meters squared. So yun ang area nito. And then ito, we can easily identify the area here by 1, 2, 3, 4, 5, 6, 7. So this one is 7 square meter. So kada isang bloke na yun, ang tawag po doon unit area square. Okay? So again, that's just an approximation, but it helped out to us, especially when we're doing analysis. Ano, ito, unit area approximation can also be represented by a two-dimensional array or a matrix of number. Ito po yung array or a matrix of numbers. Itong matrix of number, medyo komplikado. Ano, kaya po kami, mas piniprefer namin yung may grid lines dito. Kasi halimbawa ito, so titingnan mo, ito yung area niya. Compare mo dito. So mas madaling ma-identify kung may squares na. Madaling ma-measure. Okay? And then ito yung 3. Ito yung 4. Diba? Medyo complex. Ano? And then ito yung 5 natin. Okay? Unlike dito na mas madali. So we prefer to use itong naka-array na siya or naka-matrix. Naka-array na siya rather than a matrix of number. Also, it's easy to manipulate, determine adjacency, but difficult to visually interpret. Okay, halimbawa ito. Adjacent ba yung 5 sa 1? Yes, adjacent sila. Adjacent ba yung 5 sa 2? Yes, adjacent sila. Adjacent ba yung 5 sa 4? Yes, adjacent sila. Nawa yung 4, adjacent ba sa 2? Yes, adjacent. Adjacent ba sa 3? Yes. Adjacent ba sa 5? Yes. Okay, unlike nga po yung ating dati na block diagramming, 5 sila. Ayan, ito si 1, ito si 2, ito si 3, ito si 4, ito si 5. Sorry, ito si 4, ito si 5. Halimbawa, ayan. So, ang 5, adjacent, adjacent, adjacent. So, tama naman so far. Pero itong 4, adjacent ba siya sa 2? Yes. Adjacent ba siya sa 3? Yes. Pero dito sa ating block diagramming na una, adjacent ba siya sa 1? Yes. Pero dito, adjacent ba siya 1? Hindi. Nakuha? So that is why mas magandang i-consider or tama lang talaga na i-consider natin yung area required. Okay? Kasi may mga instances na pag ganito lang yung ginawa nating analysis, nakikita natin adjacent, but in reality, hindi pala pwede. Okay? Okay. So, ayan. So, any grid assigned to department must be reachable from one other grid. So, ito po. And we must avoid any kind of void or enclosed void or yung atrium. For example, ng atrium ay ito. Clear. Atrium. Ito, yeah, we can treat this as a good plan din. Okay, pero again, it is also an atrium kasi nasa gitna siya. Ito rin, nasa gitna. Pwede namang ilagay na lang siya dun sa dulong yon, di ba? Ito rin, alanganin. Pwede naman siyang ilagay na lang dito. Or ito, i-move. I-move siya dyan. Okay? So, hanggat maaari, huwag nating i-split yung department in the same way as any of these examples. Okay? Ito, hindi rin maganda. Kasi, parang pinakomplikado pa nila. And then, nagkaroon dito ng void na naman. Okay? Okay. So, ano daw po yung mga inputs natin? So, once again, na-cover natin to. Kailangan natin relationship chart and then from to chart. And then, yun nga po, it could be for improvement. We're doing the design for improvement, construction, evaluation. And then, ito yung ating mga goals or objective. It could be total cost, i-minimize natin, total traveling cost, total number of loads na i-move. And then, we can also maximize the relationship with them. And also, we can use the prioritization matrix to maximize the total satisfaction. Okay. Ngayon, balikan natin yung adjacency based scoring. So, adjacency based scoring, ganito yung ating ginagawang formula. So, pwede daw po natin makompute yung ating total loads. Okay, which is denoted by Z. Total loads. And then, i-compare natin how adjacent to one department to another. And then, however, kung natatandaan niyo yung AEOU natin, AEOU, ayan, ito guys, mahirap yung i-compute. So that is why nagkakaroon tayo ng parang vector to represent yung mga values ng AEOU para madali nating ma-maximize yung ating load distance. Example, ito. So, let's say ito yung ating activity diagram, and then we have this from to chart. Okay, and then tinignan natin yung total loads. So ito po, again, kinonsider lang nila ito. Ito yung initial layout nila. Initial layout. Okay, so tinignan nila 1, so 4. Ang equivalent ng II4, equivalent ng OI1. So, asan yun? 1 and 5. 1 and 5. Ito po, 1 and 4. So, yan po yung kanyang relationship na na-established. Again, hindi nila dito consider yung diagonal kasi nga parang trinit na nila yung area or kinonsider na nila yung area. Okay, so tinignan nila to. So, this one is their initial plan. Ayan po, nilagay nila sa ganitong form. So, 2. Ang 2 ay U, unimportant sa 7. So, that's equivalent to 0. E, 2 sa 4. Ang E natin, 16. So, that's a 16. Then, yung I natin is 4. So, 16 plus 4, that's 20. Okay, and then kinonsider nila yung 3. Asan yung 3? Ito yung 3. U and O. U and O. So, 1 plus 0, that's 1. Then, 4 is E, which is 16. 16 plus 4. Ayan. Asa na yung 4? Ayan. So, may na-miss sila dito na isa. Ayan. Hindi nila sinama. Okay. Pero dapat kasama yun eh. Diba? Okay. And then, yung 5 natin, ayan, kulang din sila. Hindi rin na-consider. Kailangan A, 64. Ito, at ito. Okay? Or, sorry. I think na-consider nila dito na simula. Okay. So, ganito. Tama po pala. Kasi hinati na nila eh. Ulit. Yung 1, consider natin yung analysis. So, 1 sa 2, wala O and I. So, O and I. Okay na to. Nagamit na natin. Kasi baka mag-duplicates eh. Okay? Ayaw natin mag-duplicate yung analysis. Yung 4 to 1, 1 to 4. Okay? And then, number 2 is UIE. So, UIE. And then, 3, UN. Okay? And then, yung 4 natin, yung 4, kung mapapansin nyo, nalagyan ko na ng checkmark. Ibig sabihin, to avoid any duplicate analysis, so, hindi na natin siya sinama. And then, yung 5, so, ito na lang yung available sa kanya analysis. So, A, so which is 64. Okay, and then, 6, E, 16. So, all in all, ang total load distance niya, or LD na tinatawag, or just Z, ay 106 using this layout. Okay? So, kung dati, ang ginagawa lang natin guys ay ganito, block diagram. Ayan, magde-develop tayo. Or sorry, yung mga ganyan muna. And then tinitingnan natin yung AAOO. Ngayon, may initial plan tayong i-evaluate. Okay? Okay po. So, yan po yung adjacency-based scoring. So, let's try another one. Ano po kaya yung possible layout pa na pwede nating makita given itong activity relationship natin? Okay. Ano po yung plan? Initial plan. Kasi we're trying to beat this one. This 106. Can you suggest any plan using this activity layout or activity relationship? Yeah, pwede yung 3 ay nakaganito kasi wala namang given na area so mahirap masabi. But definitely, pwede tayong mag-consider nun. Ito, sorry, hindi ko na-mention. This one is a measure of rectilinear. Kumbaga, hindi natin kinonsider yung diagonals. Kasi depende yan sa analysis na gagawin mo. Okay? Posible kasi, kung block diagram nga naman, yung pinto, ayan, ito yung pinto halimbawa, hindi nga naman siya adjacent dito sa milling. So, dadaan mo siya ng screw before milling process. Okay? So, okay, let's say ito yung plan ko. 1, ayan, 1, 2, 3, 4, 5, 6, and then here is your 7. Okay, yan yung plan ko. So, titingnan ko dito, 1 to 2. Anong relationship ng 1 to 2? E. So, I have here an E. Then, 1 to 3. 1 to 3 is O. And then, we have, ano pa? 2 to 4. Okay, nasan yung 2? 2 to 4, E. Tama? So, ito. Tapos, 3 to 4. Ito yung 3. To 4 is U. Okay, and then 3 to 5. 3 to 5 is U. And then 4 to 6. Asan yung 4? 4 to 6 is U din. And then 5 to 6. Ito 5 to 6 is A. And then we have ito 7 to 5. 7 to 5 is I. And then we have asan yun? 6 to 7. 6 to 7 is E. Tingnan natin yung score natin dito. Okay. So again, ito yung weight na gagamitin natin. Unahin natin yung I and O. I and O. So 4 plus 1. Okay. Ito po. So sorry, wala na akong pwede ba yung ibang kulay na marker? Pointer option in color. Ayun, pwede. So check na to. Check na to. Next. Ito naman yung E. E na lang yung naiwan dito. E is 16 plus 16. So check. And then itong yung U na yun. May na-miss ba tayo? Wala po. Yung U natin, 0. So check. Yung U na yun, 0. Plus yung U na yun, 0. Yung A na yun, 64. Yung I na yun is 4. Yung E is 16. Okay, so all in all, mas mataas pa rin, I think, ito kesa dito. Tama? So we have 20, 20, 20 plus 20, 40, 104, 105. 105 lang yung score natin dito as compared dito na 106. So much better pa rin yung layout na to kaysa dito. So definitely you can do again trial and error muna dito kasi yun lang yung option natin. But we can then compare one layout to another. Okay guys. So meron ba kayong suggested layout dito? Or okay na po tong sample na binigay ko? Anyone? Okay, so I'll consider that as wala na. Okay? But siguro, lagay natin to as an assignment. Ano? Or I think I have another samples. Okay, so again, that is one of the ways to compare one alternative to another using adjacency-based method. Another popular method is itong tinatawag nating pairwise exchange method. So pairwise exchange method, ito po yan, yung procedure niya. Calculate the total cost for the existing layout for each iteration, evaluate all possible changes, then select a pair that the results in the largest reduction in total cost and recompute the matrix each time an exchange is formed, and if the lowest total cost for your next iteration is worse than the total cost for the previous iteration, the procedure is then terminated. For example, iteration 1, 2, and 3. Ito yung po yung ating initial layout, 1, 2, 3, 4. Ngayon, pag change mo, meron kang bagong layout. Pag change mo ulit sila, meron kang another layout. And then, hanggang sa makuha natin, magpatuloy-tuloy hanggang sa ma-minimize natin yung total cost. Example, this is the prompt to chart. Okay, ito po yung values niya. And then, ito po yung flow niya or frequencies, sabihin natin ganun. And then, ito yung distances. So, 1, 2, 3, 4. Ito yung initial layout. Ano po yung score niya? 1, 2, 5. Paano po nakuha? Again, you're just multiplying it 2. So, 1. Okay, tingnan natin to. So, Z is equal 1 to 2. 1. Okay, 1 to 2. Ano ang distance niya? 1. I-multiply mo dito sa 10. Plus. Okay, ito po. 1 to 3. So 1 to 3 is 2. Multiply by 15. Plus 3. Multiply by 20. Nakuha? Okay, and then ito, sorry, plus. So okay na to, okay na to, okay na to, okay na to, okay na to. Plus 10 multiply by 1. Okay? Kasi ito yung initial layout. Plus 5 multiply by 2. Plus 5 multiplied by 1. I think that results sa 1, 2, 5. So we have 10, 30, 40, 40 plus 60, that's 100, 120, 125. Okay? Ngayon, ano po yung may biggest flow dito? So, trinay nila yung 3, 2. Ni-change nila, ni-exchange nila yung 3 and 2. Okay? So, ibig sabihin, yung ating from 2, mababago. So, ang ating bagong from 2 is 1. Or sorry, ito si 1, 2, 3, 4. Mababago natin yung from 2 natin. Siguro dito ko na lang ilagay para hindi nakakalito. Yung from 2 natin ngayon, mababago. Okay, from ito. Okay, yung 3 to 2. Siguro ilagay natin dito. 3, 2, 3, 2, 1, 4. Okay? Or siguro mas okay na. Okay. Paano kaya natin ilalagay siya sa mas better way? Wala pa. Okay. I think mas maganda. Paano kaya ilagay ito? So, pag nilagay ko 1, 2, 3, 4, mas madali bang i-analyze na pag ganun? Sige, okay lang. 1, 2, 3, 4. I-review na lang natin dito. And then 1, 2. Para hindi, kasi masyadong, pag change ko yung sequence nito, either of the two, medyo mas komplikado na siyang tingnan. So, tingnan na lang natin dito. So, ito yung matrix niya. Okay. Okay. So, yung 3 to 2, naging 1 na lang. 3, or unahin natin yung 1 to 2. Ang 1 to 2, retain tayo sa 1. Ang 1 to 3, magiging 2. Sorry, 1 to 3 magiging 2. And then 1 to 4 magiging 1. Okay? And then, again, yung distance. And then ito naman po, yung 2. 2 to 3. Gaano kalapit? That's 1. Yes. Okay, sorry. Ayan. So, okay, ito, paano naging 1 to 1? Okay. So, ito po si 1. Okay? Tama? So, ito po tayo, iteration 1. So, 1, so dikit siya. So, ang layo niya is 1. 1 sa 2. 1 sa 2 ay 1 yung layo. Okay? Isang cell. Okay? Yun yung layo niya. Yung 1 and 4, ang layo niya is 2. Sorry, 1 and 4. 1 and 4 is 1 din. Pero yung 1 and 3, gaano kalayo yung 3 sa 1? 1, 2. That's 2. Nakuha? Nakuha po? Nakuha ba yun or hindi? Okay. Okay, dito na tayo sa 2. 2 to 4. Gaano kalayo yung 2 to 4? 2. Ngayon, 3 to 4. 3. So ito, i-multiply natin dito. That results sa, ano po yung z natin? Z is equal to 10 multiplied by 1. Ito kaya ganito yung ginawa kong sequence. Ni-retain ko 1, 2, 3, 4 para hindi masyadong nakakalito dito. Okay? Hindi po. Ang iteration na to, ayan, calculate the total cost for each iteration. Select a pair that results in the largest reduction in total cost. Okay, so this one po, okay, ito guys, yun nga, mag-determine ka ng parang trial and error. Okay, so you can start with 1, 2, 3, 4 and then 1, 2, 4, 3. Ayan, and then babalik ta rin mo hanggang sa parang mag-come up ka sa best iterations or yeah, best layout. So ito actually, ito yung komplikasyon nitong pairwise method, exchange method. Kasi nagkakaroon tayo ng transfer hanggang sa magkaroon ka ng best layout na mami-minimize natin yung Z. So, yun. And actually, kung titingnan natin tong layout na to, ito po, tingnan natin to. Ang initial, parang ang pinakamaganda na dyan, again, 1 is to 4 yung ating grid. So, yung 1 and 4 kailangan magkadikit. Diba? Kung tayo po yung mag-a-analyze, ito si 1, ito si 4, kailangan magkadikit. And then yung 3 and 1, kailangan din magkadikit. And then yung 2, saan natin itatabi yung 2? Kailangan malapit siya sa 1, pero hindi pwede. Or malapit siya sa 3. Ayun. 2, 3, 1, 4. Okay, again, that is our tansyahan using this, knowing this flow matrix. Okay? Ito guys, yung 3 to 1 sa ngayon given. Pero definitely, yung ating first iteration, you can just pick this one and then make some other exchanges, trial and error until you'll come up with the best possible layout. So imagine, if we have, let's say, 9 departments and the grid is like 3 by 3. Diba? So masyadong komplikado itong pairwise exchange method. Tama? And actually, yun yung caveat dito. The method does not always guarantee yielding the optimal solution, only local optimum. And then final solution depends on your starting solution. And it can be easily accomplished if they are of the same size. So yan, again, this is just a method of evaluating your layout. Hindi natin masasabi na na-achieve na natin yung optimum. Okay, kasi nga marami tayong magiging iterations dito. Okay? Okay. Pero may gagamit tayo ng software dito eh, or yung may add-ins sa Excel para mas mabilis yung analysis. And hindi ko sinasuggest itong pairwise. Kasi nga mas komplikado siya pag i-consider na yung area. Mas maganda yung ating first step, di ba? Na nagba-block diagramming lang tayo na kagaya nito. Tama? Okay? So, ayan, i-consider since nga nasa lecture siya, so yan na lang natin. Pasadahan lang kumbaga. Okay. So, 3 to 1, 4. Hold on, may isa pang nag-add. Okay, so 3 to 1, 4. Tingnan natin to. So, 10 times 1 plus 2 times 15 plus 20 times 1. Then plus, sorry, keep. Oh, hold on, nawala. Ayan. And then plus, but hold on ha. Nag-iba ng kulay. Yung color. Okay, and then plus, nasa na tayo? 20, and then 10. Ito po. Sorry, tapat-tapat lang yan. 10 times 2, kaya po pairwise. 10 times 1 plus 5 times 2 plus 5 times 3. So ano pong total? We have 10 plus 30, 40, 40 plus 20, 60, 70, 80. 80 plus 15, that's 95. Tama? Nakuha po? Again guys, kumbaga itong method na to parang pinahirapan lang tayo sa ating unang logic. Yes. Oo. Not necessarily. Not necessarily. Pwede rin siya actually na 2 by 2. Yun nga, kaso mas magiging siya mas komplikado. Diba? Again, it varies on your first. Final solution depends on your starting solution. So if our layout is just 1 by 4, so lahat na ng susunod na layout natin, lahat ng susunod na analysis 1 by 4. Ano? Which is, ayun, hindi siya makatotohanan. Di ba? Okay? Yeah, pwede po yung 2 by 3. Or sorry, 2 by 2. Pwede naman po kaso mas komplikado siyang tingnan. Yeah, yun. Kung yun yung starting point, walang problema. So try natin. Yan. Halimbawa, starting point mo 1, 2, 3, 4. Okay? Pwede yan. Walang problema. Okay? Ito, so pwede nating i-treat siya. Depende yun sa analyst. Kung i-treat yung diagonal as 1 po or as 2 units. Kumbaga, ito diagonal 1. Diba? Sa Euclidean. Pero sa rectilinear, dalawa po yung equivalent niya. Nakuha? Pwede po na mag-start tayo sa ganito. Walang problema. Wala po. Kasi hindi ito makatotohanan. Okay? Ito pang CIE lang to eh. Pero hindi naman makatotohanan to. Kasi alam mo may area naman di ba na kailangan kang i-consider. Tapos ganito yung gagawin mong layout. Hindi siya makatotohanan. Agree? Ayun. Okay, sige. Okay. So, tingnan lang natin to. So, ito po yung ating initial, actually, pagtitingnan lang natin tong flow matrix. Ito yung ating layout. Ano? Pero, ayun nga, pwede nating makita doon. 1, 2, 3, 4. Same flow na lang ulit tayo. 1, 2, 3, 4. Okay. So, ito po. Ito yung layout natin. 1 to 2, gaano po kalayo? Dalawa. 1 to 3, 1, 1. Then 2 to 3, that's 1. 2 to 4, that's 3. 3 to 4, That's 2. Then anong score niya? Okay, z is equal to 10 times 2 plus 1 times 15 plus 20 times 1 plus 1 times 10 plus 5 times 3 plus 2 times 5. Okay, so 10, 20 plus 15, 35, 55, 65, 80, 90. Nakuha? So z is equal to 90. So once again, this pairwise method, exchange method, ginagamit siya in comparing your layouts. Kasi kung minsan, ang hirap ma-justify na ito yung best. Ano? So, yung management, kung minsan, kinukuhanan tayo ng quantitative analysis. So, definitely, you can make use of this. Yun nga lang, hindi siya ganun makatotohanan. Okay? Questions? Nakuha po itong pairwise, yung approach niya. Kung paano ginagawa. Okay. Next, graph-based method. So once again, yung ating ginagawa last time, wala tayong ginagawang computation. Nagba-block diagramming lang tayo based on our intuition. Tama? So this time, may computation na tayong kukunin. Okay, so sa graph-based method po, you have to select a department pair with the largest weight. Ties are broken arbitrarily or your choice. And then select the third department to enter based on the largest sum of the weights for the first two departments. Pick the fourth department to enter on the face of the graph, a bounded region for the graph, and then determine an adjacency graph. Then construct a corresponding block layout. So your goal here is to maximize the total weight. Okay? For example, this one. Okay. So, again, may distances na siya or may flow na siya. Okay? So, arc 1 and 2, that is 9, yung weight. 1 to 5, that is adjacent. 1 to 5, that is 0. 2 to 3, that's 12. Ito po yung 2. Ito yung 3. That's 12. That's 4. That's 2 to 4 is 13. And then pagpa-plus-plusin lang po, nakuha natin 63. Ngayon, ito yung another layout natin. So, kita nyo yung comparison. Nasaan si 1? Ito yung 1. Yung area na to guys ay equal sa area nun. Okay? At maya-maya may sample po tayo na ganyan. Okay. Then 1 to 5. Kung mapapansin nyo dito, 0. So 0. 2 to 5. That's 7. Okay. And then so on and so forth. Nag-result siya 71. So mas mataas itong layout na to kaysa dito. Okay, that's the comparison being done here. Question. Ngayon, gawin natin siya. Okay, so sa graph-based method, kinukuha natin yung data mula sa relationship chart. So ito yung relationship chart. Dadalhin natin sa relationship diagram, map. Kita naman na kung paano 1 to 2. Ito yung initial layout natin. 1, 2, 3, 4. Okay? Question about this one sa relationship diagram? Kayang mag-translate? Again, initial layout, yung ating, ito, kailangan kasi dito ng initial layout. Okay? 1, 2, 3, 4, 5. Questions? Nakuha naman ano? 2 to 4, 2 to 4, that's 13, that's 13, 20, 3 to 4. Okay, so, ngayon guys, before we proceed dun sa graph-based method, pwede ba kayo mag-suggest dito ng possible layout that will best fit ito? Yan, ito po. That will best fit nito. Kung yung ating dating approach. Siguro, titingnan. Ganito, di ba yung gagawin natin? Ito si 3. Iko-connect ko sa 4 kasi yun yung 20. Pinakamataas, 2 to 4. Okay, ibig sabihin ito si 2. Okay. Then 2 to 3. Okay. Kailangan magkadikit sila. Okay? And then, ito yung dating approach natin, 1 to 4. Okay, dito ko muna si 1. And then, ito 9, 1 to 2. Kailangan magkadikit din sila. And then yung 8, 2 to 1 to 3. Okay? And then 2 to 5, kailangan magkadikit si 2 to 5. And then 4 to 5. Okay. So, yan yung ating initial. Kung ilalagay natin siya sa block diagram, parang ganito yung magiging analysis natin. So, paano kaya natin ma-address to? Anyone? 3, tapos 4 dito? Sa baba? Or dito? 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 Sorry, dito? Dito natin ilalagay yung 2? Try natin. Then, so dito yung 2. Again, intuition. Tapos, saan yung 5? Saan yung 1? Dito yung 1? Dito? Then 5? Katabi ng 4? Katabi ng 2? Or, balik na rin natin. Ito si 1, ito si 2, ito si 5. Pwede? Okay. So, masasabi natin, ito yung ating analysis based on our intuition. Tama. Trial and error natin. Agree. Ito na yung so far yung best natin. Ngayon, tingnan natin yung approach dito sa graph-based method. Okay? Okay pa? Okay. So, nilagay po to sa relationship diagram. Nakagaya nito. Walang problema. Walang problema dito sa paglalagay sa relationship diagram. Again, nag-build siya ng initial layout niya. Okay? After nyan, ito na yung step niya. First step daw, select a department pair with the largest weight. Ano po yung largest weight ng mga departments? Pinakamalaki, 20. So, ipipick daw po natin siya. Ito si 3, ito si 4. Okay? Next step. Ayan, select the third department to enter based on the largest sum of the weights with the first two departments. Okay, so na-pick na natin yung 3 and 4. Iko-compare naman natin siya sa other departments. Ano po yung other departments natin? 1, 2, and 5. Okay, ano po ang relationship ng 1 and 3? 1 and 3, 8. Nakuha? Nakuha po? 1 and 4, ano yung relationship? 10. Okay. And then, 2 and 3. 12. And then, 2 and 4, 13. Then, 5 and 3. 5 and 3, that's 0. And then, 5 and 4, that's 2. After nun, isasum lang natin, 18, 25, 2. Ipipick natin yung 2. Ibig sabihin, guys, nito, magkakatabi dapat yung 3, 4, and 2. Nakuha. Ito po. So, kinonstruct natin yung 3 and 4. And then yung 2, nilagay natin doon. Again, this is the algorithm na ginagamit. Yung una natin ginawa, trial and error, di ba? Pero may algorithm din po behind that. Okay? Nakuha. Yung 2, nilagay natin doon. Okay? After nun, okay? So after nun, next step, select the third department to enter based on the largest sum. So yun nga po. Ayun, nilagay nila yung 2 doon. And then yung tira, 1 and 5. Okay? Tinignan uli yung relationship dito. So tingnan natin kung 2, 3, and 4. Walang problema sa sequence. And then tira ay 1 and 5. 1 to 2, gaano medyo na mahirap. 1 to 2. Ang hirap tingnan dito sa relationship. Mas preferred ko tong relationship chart. 1 to 2, that's 9. 1 to 3. That is 8. That is 10. Nakuha? 5. That 5 to 2. That is 7. And then 0, 2. Nakuha? And then total. Mas malaki to. So yung 1, itatabi daw doon. Kaso, ganito yung nangyari. Sa gitna siya nilagay. Nakuha? Ilalagay lang din po siya sa gitna. Nakuha? Kasi, again, dalawa lang yung starting point, then 3, magkakaroon tayong triangle, then ilalagay natin sa gitna yung pinakamataas na sunod, which is 1. Okay? Questions? After nyan, select the fourth department. So, yun nga po. And, i-enter daw po natin sa face, which is dito daw po. Area bounded by, ayan, bounded region of a graph. So, which is yun nga, nasa gitna. Then, determine adjacency graph and then construct a corresponding block layout. So, iwan na lang ay 5. Tama? Ngayon, tiningnan natin, halimbawa ito, yung mga faces. Saan ba dapat natin ilagay yung 5? Okay? So, tiningnan muna natin, what if dito natin ilagay? Di ba nahati siya sa 1, 2, 3? What if dito natin ilagay yung 5? Anong impact? Ito si 5. Okay? So, ayan. So, titingnan natin. Ilagay siya sa face. Sorry, inuna nila dito. 1, 2, 3. Para ito yung naging sequence natin. Pag nilagay nila dito yung 5, okay? Parang ganito yung maging analysis. 1, 2, 3. Tatlo lang muna. Then 5. Okay? Then, balik tayo dito. Okay, ayusin na natin. 1, 2, 3. And then 5. 5 to 1. So that is 0. Okay, then 5 to 2. 5 to 2, that is 7. And then 5 to 3, that is 0. Anong total? 7. Okay? Ayun, second option. Ayun yung 7. Second option. Dito ko ilagay. Again, this is the first option. Sorry. This one is the second option. Kasi tatlong option mo. Ito yung third. Nakuha? Nakuha pa? Okay. So, third option, actually, 4 kasama yung 2, 3, 4 na yun. Okay, so third option natin is, second option, sorry, is ito, 1, 2, and 4. Ito si 5. I-compare lang natin. Kunin lang natin dito. 1, 2, and 4. Ito si 5. So, 5 to 1, that is retained as 0. 7, 1 to 4. Sorry, 5 to 4 is 2. So, anong total? 9. Okay? Another option natin. Tingnan ulit natin dito. 1, 3, 4. Okay, 1, 3, 4. Ito si 5, 1. 5 to 1 is 0. 5 to 3 is 0. 5 to 4 is 2. So, dalawa lang. Okay? So, nakuha na natin yung faces. Sana, yung tatlo. Kaso, tinignan din natin yung other possible option, which is yung 2, 3, and 4. Ayan, parang ilagay lang natin sa gitna. Which is, ayan, regardless of 1. Regardless of 1. Okay? So, tingnan natin. Dito si 5. Sorry. 2, 3, and 4. 2, 3, and 4. 5 to 2, that is 7. 5 to 3, that is 0. 5 to 4, that is 2. So, 9 din siya. So, magka-typo ito at saka ito. So, if that is the case, you can pick either of the two kung saan natin gustong ilagay. For this case, nilagay nila siya sa gitna ng 1 dito po. 1, 2, and 4. 1, 2, and 4. Doon nilagay yung 5. So, ito yung layout niya. Okay? Or ito yung adjacency graph. Question? Question? Wala po. Ngayon, magkikreate na tayo ng block diagram corresponding to that. This one is quite complicated. Okay? So, ayan. Ito, gumawa na sila ng block diagram. Ito yung area, yung 2. Ito yung 3. Okay? Ito yung ating 4. Kasi kailangan mo consider adjacencies. Okay? And then, ito yung 5 natin. Kumbaga, 1, 2, 3, and 4. Nilagyan lang nila ng square and then consider natin yung adjacencies. Kailangan, halimbawa, ito adjacent. Yung 2 and 4. Nakuha? Adjacent pa rin sila. Yung 2, nakuha yung 2. Sige. Guys, ito yung 2 natin. Adjacent siya sa 4. Nakuha? Yun na ipilit. Okay po. So, ito kailangan nating isipin paano natin magagawang adjacent. So, kung mapapansin nyo to 1 to 2. 1 to 2 yung ating adjacency. Yung kanina nating ginawa dito. Dito sa adjacency. Ganon din po yung ating magiging computation. So, 1 to 2. Asan yung 1 to 2? That's 9. 1 to 3. So, adjacent. Tama. 1. Tama. Ito yung 1 natin. Okay? 1 sa 2. Adjacent. 9. 1 and 3. Adjacent. Tama. Adjacent sila. Ito po yung area ng 1. Then, ito yung area ng 2. That's 8. Lahat adjacent. Makukuha natin yung 81. All in all. Okay? So, ayan po yung itsura niya. Okay? So, this one, again, hindi na siya yung kagaya na ginagawa natin. May missing point dito which is yung area. So, yung natin, ginagawa lang natin ganyan. Which is tama rin naman. Walang problema. Yun nga lang, may consideration na ng area. Which is, for this example, walang binigay But definitely, that should be considered. Okay, questions? Okay lang guys, ito po ay pwede natin magawa using craft. Mas mabilis dun. Pero yung concept to, sana nakuha niyo kung paano ini-evaluate. Okay? Okay. So, ito yung craft method. Hindi natin siya isosolve mano-mano. Okay, kasi magko-compute ka ng mga centroids dito Okay. So, ito yung craft. So, you have to consider yung area. Okay? So, yung area na to ay may corresponding number of grids. Halimbawa, 30 grids. Equivalent sa 12,000. 20, ito auto-compute na naman to So, kung mapapansin nyo to, yung 20 divided by 5, anong total niyan? That is, ilan po kayang square feet kada grid? Again, grid refers to yung ganyan. Okay, yung isang ganun. Okay, I think we have to go back here sa ating sample kanina. Yan, ito po. Ito yung ibig sabihin ng grid natin. Yan yung representation. Ito yung area, nire-represent lang natin sa number of grids. For example, ito yung area niya, 10,000 square meter. Yung grid 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. Yun po yung ibig sabihin po nitong grid number of grids na yun. Yung area, malinaw na naman yan sa inyo. Okay, so ilang grids po kada, or ilang square feet kada isang grid? 400. Ibig sabihin 400 square feet per grid. Sa isang box na gano'n, ang ibig sabihin yan, 400 square feet yan. Okay, so kung i-divide natin to 400, 400, 400, 400. Pare-pareho. Okay? So dito po sa craft, kailangan natin ng from to chart. And then, ayan, and then also yung relationship chart. Again, ipe-pairwise kasi natin uli sila Okay, kailangan natin yung hanapin yung combination nila kasi you're not just looking for quantitative data, but also yung qualitative data niya. So dito po, department shapes are not restricted to just rectangular ones. Again, nag-block diagramming tayo, treat natin siya as rectangular blocks lahat. Tama? Regardless of the area. But this time, kailangan natin i-consider yung area na. Okay? So our goal here is to minimize the Z. First step, hanapin daw po yung centroid. Ayan. Then hanapin yung rectilinear distance. So pag sinabing rectilinear distance, ito yung centroid. Distance niya, papaganyan, and then bababa siya doon. Nakuha? Yun po yung rectilinear distance. Questions? So yung total distance na yan. Yung centroid, mahirap hanapin. Sana agree kayo. Kaya po ito hindi natin mamanu-manuhin. Ito po gagamit tayo ng Excel. Yung add-ins doon. Okay? So ito yung departments 1, 2, 3, 4, 5. So meron siyang initial na layout. Halimbawa, you're planning to make improvement plan. Okay, improve natin itong layout natin. So ito yung initial layout niya. Okay? Questions? Hanapin natin yung centroid. Hanapin. So ito yung mga centroid. Centroid ng kada isa. See how complex yung centroids natin. And then hahanapin natin yung rectilinear distance between each centroid. Centroid na yun. Centroid na yun. Centroid na yun. Centroid na yun. Lahat. Okay? Ito yung distances nila sa isa't isa. Nakuha? Ayan. Sorry, may isa pa dun. And then yung distances. Lahat ng distances nila. Nakuha po. And then you have to consider department exchanges, determine for the estimate, yan. Then repeat the procedure until no interchange is able to reduce the transportation cost. Okay, sabi ko nga sa inyo, gagawin natin siya, software na lang. So I provided you the link kung paano siya gawin together with the Excel file. Ayan, so ito yung naging resulta niya. Okay, ngayon, pakita lang nating mabilisan kung ano pong itsura nun. So I want you guys to be more familiar dito. So let's say for example ito. Meron tayong 10 departments. Again, this is a sample na po. 10 departments meron. And then you're treating 5 by 5. 5 by 5. Okay, ito yung area, ito yung i-input mo. Area ng kada isang department. Then variable or fixed ba siya? Pag fixed siya, ibig sabihin hindi na dapat siya iibo. Okay, hindi siya iibo ng ibang location. Okay, and then ito yung from to chart. Naintindihan po? Then ito yung cost matrix. Pag sinabing cost matrix natin, so equally weighed naman sila lahat for now. Pero pwede yung halimbawa lalagyan dito ng 10 or kung anumang value. Halimbawa may kailangan mas close yung department na isa dun sa isang department. Okay, so nangyayari po yan. After nyan, i-define natin. I think na anong nagawa ko dito? 5, 10, ayan. So let's say mag-work, may pinakialaman ako dito eh. Let's say mag-work siya. Ganito po yung magiging itsura niya. Ayan, may initial layout. So mapapansin nyo dito, 30 yung cells. Okay, 30 yung cells niya. 30 yung grids. And then yung kada isang grid ay may equivalent value. Okay? So yan, nahanap yung centroid, nahanap yung sequence hanggang sa ito, na-optimal na to eh. Na-optimize na niya. Okay. So yan, provided naman yung video dito. Ayan, so ito yung example. It could be an optimal sequence or traditional graph. You may measure it using rectilinear or Euclidean. And then ito, pwede nating i-define. Then you just need to recreate it. And then magsasuggest siya ng ganyan. And if you want to like see for improvement, ayan, napapansin niyo yung improvement. Ayan, ayan, ayan. And then meron na tayong final layout pag wala nang isiniswitch. And then ito yung ating load distance na cost or yung ating Z na hinahanap. Okay? So again guys, ipakita natin to siguro next meeting. Paalis pa lang ako ngayon kaya ako pinagmamadali. Ipakita natin to next meeting, but I want you guys na maging mas familiar dito. So once again, provide natin po yung yung ito mismo, yung file. Pa-check na lang po sa group chat. Okay? And then you may try using yung mga binigay ko sa inyo na problems last time. Asan ba yun? Downloads, EDS. Okay. You may try using craft dun sa ating mga binigay sa inyong problems previously. Kaso walang cost. So, yan. Sa mga problems na to, pwede nyong itry. Okay? But definitely, please watch the video first before trying. Kasi posible magkaroon ng error, especially sa mga weights, sa mga area. Okay? Questions po. So, gawin natin to next meeting. Questions, guys? Any more questions, clarifications, or anything? Questions po? So, okay lang guys ha. Hindi na natin ito mamano-manuhing isolve at talaga may stress lang tayo sa centroids. Okay? Questions po? Questions? Any other questions? Wala? Wala na? Clear? So once again, natapos tayo dito sa craft. Tuloy natin siya next call. Okay, so kung wala ng question guys, so salamat po. Okay na? Ito guys ay save ko lang. Hindi ko pa siya na-save sa UBN. I-update ko na lang po yung ating drive dun. So any questions before we wrap things up? Mapa supply chain or facilities? Any other questions? Okay, so wala tayong call mamaya ha, na hapon. Sorry ha, paalis talaga ako every Saturday. Okay po, so again guys, enjoy your weekend and have a great day. Paalam po. Thank you po.